Hello, scientists! Welcome back to Room 9, our region's largest classroom. My name is Mrs. Stobbs, and I teach kindergarten in the Maplewood-Richmond Heights School District right here in St. Louis. And today, I'll be teaching a science lesson for kindergartners and for preschoolers, but of course, learners of all ages are welcome to join me. So are you ready? All right, let's have some fun today. All right, my friends, I am outside at a little pond in a neighborhood. And as I was walking, I noticed the geese. Do you see the geese? Have you ever watched geese before? Now, geese can sometimes be a little mean, so you need to stay away from them and keep your distance. But right now, they're kind of peaceful and they're just watching us. But what do you notice about the geese and where they are in the water? Are they under the water or are they floating on top? They are floating on top. Huh. Now, whenever you swim in the water, do you float on top of the water like a goose? Or do you sink down farther to the bottom? Whenever I'm thinking about going swimming, I know that sometimes I'm up at the top, but sometimes I go closer to the bottom too. But either way, I have to kind of work hard to keep myself either at the top or swim down to the bottom. And if I really want to be floating on the top, what do you have to do? What would I have to do if I want to float on the top? I'd have to lay on my back and spread out my arms and legs, and that would keep me from sinking to the bottom. I wonder if that helps us whenever we're thinking about how things sink or float. You know what? That is what we're going to be talking about today. About how we know or how we can see if things sink or float. How we know if things will sink or float. So we can see that these geese are floating on top of the water. But I want to check some other things too. And if you go on a walk with your family, you can do this too. You can find things that you can find around the lake, natural items. Don't throw anything into the lake that doesn't belong there. But if you want to find some leaves or a stick or a rock, you can drop it in the water and see if it sinks or floats. Now, if you see an animal, should you throw anything at the animal? No way. That would be very mean. But you can drop things into the water that belong there, things that would be around there anyway. Don't bring your toy and throw it into the water, because first of all, that would be sad because you would lose your toy, but it also might hurt the environment and an animal might try to eat it. All right, so I have some natural items and I want to see if they're going to sink or float. So my first thing I want to test is a stick. Do you have a prediction? If you think it's going to float, put your arms up high in the air. If you think it's going to sink, put your hands down low to the bottom. Oh boy. All right, let me see what's going to happen. I'm going to toss it in. What's happening? It's floating. It's floating to the top. Sticks can float. All right, let's see. How about a pine cone? Do you think it's going to float? Arms up. Do you think it's going to sink? Arms down. All right, let's see what's going to happen. It is floating too. Look at that. Okay, my next thing is a piece of tree bark that I found on the ground. You think it's going to float? Arms up. You think it's going to sink? Arms down. Let's see. Ooh, it's floating. Okay, what about a rock? If you think the rock is going to float, arms up. If you think it's going to sink, arms down. Let's test it out. Whoa! It sank to the bottom, and it made a fun sound whenever it sank to the bottom too. So now we know that rocks sink to the bottom. Okay, what about an acorn cap? You think it's going to float? Arms up. You think it's going to sink? Arms down. Let's see what it's going to do. Ooh, it's floating, and it even flipped over. Floating in the water. Okay, what about a leaf? Let's test it out. Oh, first of all, make your prediction. Arms up if you think it's going to float. Arms down if you think it's going to sink. Let's see. Ooh, it it's floating. However, I notice, and I don't know if you can see it on the camera, but I notice that there are some leaves that are under the water. I wonder why that is, why our leaf is floating, but there are some leaves that are sinking. We're going to have to keep that in our mind, and maybe we can find out that answer later on today. All right, I have one more. How about some pine needles? Let's see what happens with these pine needles. Ooh, they're floating too, but again, I see some that are under the water. So I wonder what that would mean, why that's happening. All right. Well, my friends, we have a little bit more learning to do about sink and float. So let's go back to our classroom and let's read a book to find out more. All right, my friends, so we're back in our classroom and now we're going to learn a little bit more about sink and float because we observed how different objects either sank or they could float to the top, but we also were wondering, why is that? Why do some things sink and why do some things float? So you know what? We're going to be like scientists and read a book to find out. We're going to learn from other scientists. But my friends, before we start reading, I want to show you that I made a chart to show our observations from the lake. So I wrote float and sink at the top. Float, sink. And then I drew pictures of the things that could float and the things that sank. So I said that the leaf floated to the top, the pine needle floated, the stick could float, the tree bark could float, and the pine cone could float. And then I said over here, the rock sank. Remember that cool plop sound it made? But I also noted that we did see some leaves and some needles that had sunk to the bottom of the lake. And we were wondering why that is, because whenever I threw the leaf and the needle in, it floated to the top, but there were some that were at the bottom. So that's a question that I think we want to figure out. But we also just want to know, why do some things sink and why do some things float? So let's read a book and find out. This book is called, Does It Sink or Float? That fits perfectly with what we're talking about. Does It Sink or Float? It's by Susan Hughes and it's published by Crabtree Publishing Company, and they gave me permission to read this book to you. Oh my goodness, remember, in every informational book, we have a table of contents that will tell us where to find information. What is matter? That's the heading of this page. All objects are made of matter. Matter is anything that takes up space and has mass. Mass is the amount of material in an object. So a tiger, flowers, and everything you see around you is made of matter. You are made of matter too. Have you ever heard that word before, matter? You may have heard maybe that something doesn't matter, or maybe someone has said to you, you matter, you're important. But matter in the science word, like I said, is anything that takes up space and has mass. But it's anything that you see around you. What are properties? Matter has properties. Properties describe how something looks, feels, tastes, or sounds, or smells. We can taste this lemon to learn if it is sweet or sour. Sweet and sour are properties that describe how something tastes. We can look at this Ferris wheel to learn about its shape. Shape is a property too. That kind of sounds like our five senses. Whenever we are using our five senses, we're looking at the properties of matter, right? Oh, here we go. Float or sink. Properties can also describe how something acts. An object can float or sink depending on what material it is made of. Ooh, that's something important to remember. It can float or sink depending on what type of material it's made of. For example, some things float or stay on the top of liquids such as water. Other things sink or fall to the bottom of a liquid. So look, that glacier is floating. Now, are glaciers light or are they heavy? Glaciers are huge, huge, huge chunks of ice. So they are very, very heavy, but yet they're floating. And then look, a cup. Is a cup heavy or light? It's not the lightest thing, but it's pretty light. You can lift one up, but it might sink to the bottom. Objects that float are described as buoyant. Can you say buoyant? Buoyant is kind of a fun word to say. Buoyancy is a property of matter. And this little kid is bobbing for apples. Have you ever done that? Look, apples float, and you can play a game where you try to bite an apple as it's floating in the water, using only your mouth. So you dunk your head in and you try to grab an apple with just your mouth. Does it float? Rubber ducks float. They are fun bath toys. If you have a rubber ducky in your bath, can you go quack, quack, quack? I don't have one, but I know they're pretty fun. Water wings float. This girl is wearing water wings on her arms. They can help her learn to swim. Do any of you wear something like this whenever you go swimming? That might help you float. Remember we were talking about whenever we're in the water, we kind of have to work to stay on top of the water. But sometimes if we have water wings or maybe a vest, it helps us float. Canoes can float. Oh, look at that. That's a pretty big boat, but it can float. People use them to travel over lakes, rivers, and oceans. Why do all these objects need to float? Why do we need a boat to float? Oh, that rhymes. Boat, float. Because then we can travel using the boat, right? It makes it easier to get across water. Why might we need water wings or maybe a life vest? To keep us safe so we don't sink to the bottom. Does it sink? An object sinks or floats depending on its properties. An anchor sinks so it can keep a boat in place. Have you ever seen an anchor before? Boats let them down and then it keeps the boat from floating away. Stones sink. Oh, we learned this. We use them to make stepping stones across water. So even little stones sink, like the one that we used at the lake, but also big rocks sink too. A net can sink. People use them to catch fish. Some nets have floaters to keep them from sinking to the bottom of the ocean. That surprises me. Do you think that a net would sink? It looks like there's lots of holes in it that would keep it floating, but it says that they sink to catch fish. Why do all these objects need to sink? Just like on the other page, they have special jobs to do. So I think probably a scientist engineered some of these objects, designed them to make them sink. Why do things sink or float? Oh boy, here we go. This is the question we were wondering. Objects are made of materials which have density. Ooh, that's a big science word. Density. Can you say that? Density. Density is a measure of how closely together matter is packed. An object with low density floats in water. It is made of material that is less dense than water. This lid can float because plastic is less dense than water. I'll show you that page. So there's a plastic lid and it's floating. It's less dense. An object with high density sinks in water. It is made of material that is denser than water. These coins sink because metal is denser than water. And so now they put a bunch of coins on top of that lid and it made the lid sink to the bottom because the coins are denser than the water. There's a little question mark. It says, wood is a material that is less dense than water. So knowing that, do you think a toothpick would float or sink in the water? What do you think? It says wood is a material that is less dense than water. So think about what you know about a toothpick. What is the toothpick made out of? It's made out of wood. And so do you think it's going to float or sink? It's going to float. And maybe we can test that out in just a little bit. High density or low density? Rocks are denser than water, so rocks sink. Objects made of metal usually sink. A steel diving cage sinks. Ooh, look at that. That's how sometimes some scientists observe sharks. They put themselves in a steel cage and then they can see the shark without the shark getting to them. A feather is less dense than water. It floats. A lily pad floats on water. It is less dense than water. So I wonder if that means a leaf and a needle and a stick and a wood chip from a bark from a tree and a pine cone. I guess that means that they are all less dense than water. And I'm thinking that all of those things, they come from a plant or come from a tree that's made out of wood. But I'm still wondering about the leaf and the pine needles that were under the water. Just add air. Some objects have air in them. This helps them float. A rubber boat can float. So does a beach ball. Have you ever played with either of those? Or maybe you have an inflatable that you play with in the pool. A submarine. Ooh, do you know what a submarine is? A submarine is a special boat that can go under the water, and it can travel under the water. A submarine has special compartments or sections. When they are filled with water, the submarine is denser than water. It sinks. When the compartments are filled with air, the submarine rises. Now it has less density than water. Okay, so what it's telling me, there's a picture of a submarine. And this page is telling me that a submarine has special little compartments or maybe little tiny rooms, little sections that they can fill up with water. So whenever they want to sink down deeper, they open it up and the water fills in and then they sink. But then whenever they want to rise up, they get the water out and then the submarine rises. What would happen if you put an empty bottle in water? What would happen if you filled it with sand? We might have to try that out too. So think about an empty bottle. What's in the bottle? Even if it's empty, there's air inside. So I think then it would float. What about if you filled it with something? It would sink. The shape of an object can also help it float or sink. A flat piece of plasticine floats. And I think that probably is kind of like clay. A round solid ball of plasticine sinks. So it depends on what shape you make it. And we're going to play around with that too. Rubber flip-flops float because they are very flat. Imagine you want to float in water. Will you curl up in a ball or will you stretch out flat? We talked about this at the lake. Remember we said if you want to float on water, you stretch out and usually you lay on your back and then you can float. And think about if you want to do a cannonball. Whenever you jump off the diving board or jump off the edge, you curl yourself into a ball and you go, cannonball, and you fall down. And that's the end of this book. So friends, now we know a little bit more about why things sink or float. It depends on how dense the object is, how much matter it has, and also the shape of the object. So you know what? I think we need to explore a little bit more with some more objects from around my house to see if we can figure out why things sink and why things float. Because you know what? I'm still wondering about that leaf and that pine needle. So I'm going to go gather a few materials and then I'll meet you right back here. All right, my friends, so I have a big bucket of water that we're going to use to explore even more with sink and float. And again, this is something that you can do at home. You can get a bucket like I have, a bowl of water, or you can even just use your bathtub or the sink. Just make sure that you get a grown-up's permission because sometimes whenever you're working with water, it can get a little bit messy. All right, so my friends, I wanted to start with a question that we had. Do you remember whenever we were at the lake, we put a leaf and a pine needle in the water and they floated. But then we looked and we saw that there were leaves and needles that had sunk to the bottom of the lake. And we were wondering why that was. So we're going to do a little experiment while we, to test that out. So I don't have a leaf right now, but I have a piece of paper. And a piece of paper is kind of like a leaf, right? They both come from trees. And so I'm going to put this leaf in the water and see, or this piece of paper in the water and see what happens. So right now it's floating. But what if something came along and pushed it into the water? Now what's happening? Is it still floating? No, it's sinking. So I wonder if that's what happened to those leaves. That maybe they were floating, but then something knocked them down and made them sink. I also want us to keep on watching this paper. I don't even know if you can see it, but I see some little bubbles coming off of that paper. I think maybe there was a little bit of air in that paper, and now the air is coming out, and now it's soaking up the water. And I'm wondering if that's what happens with leaves. I think that is. I think leaves also soak up some of the water, and that's why they sink down to the bottom. So we'll keep this in here as we explore a little bit more with our other objects, all right? Okay, the next object I wanted to check is a toothpick. This was in our book, and our book said that a toothpick is made out of wood, and wood is less dense than water, and things that are less dense than water float. So what do you think about this toothpick? Will it sink or will it float? Can you show me with your hands if you think it'll float? Hands up. If you think it'll sink, hands down. Let's see. Ooh, it is floating. And watch what happens whenever I push this down. It pops right back up. It's not like the paper that stays down at the bottom, but it pops back up. So a toothpick definitely floats. So let's add that to our chart. I'm just going to draw a really thin line for a toothpick because toothpicks are really thin. And I'm going to put a T for toothpick. The next thing that our book asked us to check out was a bottle, an empty bottle. And now I don't have an empty bottle, but I do have an empty cup. And so this is a cup. You can see it's fully empty. Let's see what happens whenever I put this in the water. Do you think it's going to sink or float? Oh, I see a lot of you saying float, float, float. Let's try it. Oh my goodness, it is definitely floating. And look, I can even make it dance across the water. It's almost like it's ice skating. So an empty cup floats, and I bet an empty water bottle would too. But now let's compare that with a cup of water that is full. Look how full that is of water. Let's see what happens whenever we put this in our bucket. It sank to the bottom. Now it's floating a tiny, tiny bit still. It's still kind of dancing across the bottom of the container, but it still has sunk. It's not floating on the surface. It has now sunk. So let's draw that on our chart. We're going to put a cup here, an empty cup, and then I'm going to draw a cup, but I'm going to draw it full of water on the sink part. All right, let's see. Ooh, the next thing I want to check is a ping pong ball. Have you ever played with a ping pong ball before? Ping pong balls are really fun. They're very light. They're full of air. They're hollow inside. And they're really fun to play with. Now, if it's full of air, what's your prediction? Do you think it's going to float or do you think it's going to sink? Think about what we talked about with your inflatables that you use at the pool. Oh, I see a lot of friends going like this. Float, float, float. Let's test it out and see. It is. It's floating. I can make it dance across the water. Now, what about another ball? So this is a marble. I want to show you. They're both round. They're both balls. But this one's hollow. And a marble is solid. It's full of glass. It's just a glass marble. Full, it's completely solid of glass. Let's see what happens whenever we put the marble in. So I'm going to put the ping pong ball back up. We know it floats. Let's see what happens to the marble. Did you hear it? It went clunk and it sunk to the very bottom. And I think that the reason why is because, again, the ping pong ball is full of air, but the marble is not. It is solid. So let's draw those on our chart. I'm going to draw a circle, and I'm going to write P for ping pong ball. And then I'm going to draw a circle and put an M for marble. All right, let me move my ping pong ball out of the way. I think I'm actually going to move my marble out of the way too because it's on top of the paper. And let's just check out our paper right now. Is it still sinking? It still is at the bottom. It hasn't floated back up. So I think that's why our leaf and our pine needle, why they were on the bottom, but then the new ones that we put in were floating. All right, let's see. I'm going to try out a paper clip now. Let's test out a paper clip. Now, paper clip's made of metal, but there's lots of empty spaces around it. So do you think this is going to float or do you think this is going to sink? Show me with your hands. Float or sink. It's pretty light. Let's see. It sank, even though it was so light and there were lots of holes in it. Why do you think that was? I'm going to tell you. You know why? The reason why it sank, even though it's so light, it's because it is so thin that there was nothing for the water to spread out on and to hold on to keep it floating up at the top. So everything just went right through, and then the paper clip sank down to the bottom. Wow, that was a tricky one. I thought for sure it was going to float. But you guys, it sank. So let me put it over here. So I'm going to draw that paper clip, kind of a swirl, and write a PC for paperclip. All right, my friends, we have one more thing to do, and it's Play-Doh. But just like with our paperclip, we learned that the shape matters to see if something floats or sinks. So I have two things I made out of Play-Doh. I have a ball and I have a little boat. Let's see what happens whenever we put them in the water. Okay, think about your prediction. What's going to happen? I'm going to put the Play-Doh ball in first. It sank. Now I'm going to put the boat in. And the boat is floating. Now these are made out of the same material, but the shape is different. And friends, we talked about that in our book. Remember, we said if you want to sink in the water, you make yourself scrunched up. You go cannonball, and you go like this. But if you want to float, you spread out. And then that helps keep you afloat. And so that's the same thing here, that the ball is nice and tight, and the water just goes around it. But with the boat has the water spread out around it, and then it can float on top. Oh boy. My friends, we learned a lot about floating and sinking today. And you know what? You can explore even more on your own, and you can discover even new things. I wonder what you'll find in your house that can float and sink. I hope that you have so much fun exploring today, like a scientist, and I will see you next week. Bye.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.